Hello and welcome to Intro to Block-Based Programming in Scratch. This is Lesson 2. Today we're going to talk about the Scratch screen and how it ties into the coordinate plane. We're going to briefly talk about what sprites are and what some of the blocks do. And that is all for today's lesson. Let's jump into it. So, the screen works on what we call a coordinate plane. And what that means is you start from the center and you have two numbers. You start from the center, you go left and right by the first number, and up and down by the second number. Negative numbers mean left, and negative numbers on the first number mean left, negative numbers on the second number mean down. So, for example, the coordinate 0, 100 means you take 0 steps left and right, and 100 steps up, and you would end up just above the starting point. So here is an example of the Scratch screen with two axes drawn on. And here's some examples of coordinates. So 0, 0 is the center. And this one to the right is going to be 100, 0, because you would take 100 steps to the right to get there, and you wouldn't go anywhere up or down. You would just stay there. Similarly, 0, 100 is staying nowhere left and right, you don't go anywhere, and going up 100. The other 2 points, negative 100, 0, and 0, negative 100, are the same thing, except instead of right, it's left, and instead of up, it's down. The negative simply just means the other direction. So, here is a little quiz on the coordinate plane. The goal is to figure out which of these options shows where the cat is right now. So the cat right now is at the center of the screen. So which of these coordinates would tell you that? Which coordinate shows where the cat is? The answer is 0, 0, because the cat does not have to go anywhere. The cat is already at the center. Remember, you start from the center and then you go to where the cat is. Next one. Again, start from the center, go to where the cat is. Now the cat's above, but it's not anywhere left and right. So you know the first number has to be 0. And since it's going up, you know the second number has to be positive, and our only answer that fits that is 0, 100. Similarly, we have the cat goes to the right, but does not go up and down, so the second number is 0, and the first number is positive, therefore it's 100, 0. This one is a little tricky. The cat has to go 100 to the right, and then 100 up, so both of them are 100, so it is 100, 100. This one, the cat is the same as the one where the cat moved to the right, but instead it's moving to the left. So instead of 100, 0, it's negative 100, 0. I want to go a little bit more in depth on how the coordinate plane works. So let me bring this whiteboard here. So, this whiteboard has 5 coordinates on it, and I have drawn a coordinate plane here with numbers. So, the goal here is to take each of these points and write down the coordinates. And I'm going to show you a couple ways to do that. So this A right here, we want to figure out what numbers I should write here to represent A. And you can think about it like this. You start from the middle, you go 1, 2, 3 to the left, that's negative 3. And then you go 1, 2, down, and down is negative, so negative 2. And that is how you would do that. Another way to think about it, if you're doing B, is to think, okay, instead of walking to the left and right and then walking up and down, we can just draw lines like this. Just like this. Straight across and straight down. And see what numbers it lines up on. So, the number of this horizontal line, it lands on 1, so we can just write a 1 here. And the number this lands on is 2, so we can write a 2 here. It's the same thing. Now, just for your practice. You can follow along as I do the rest of them. This C lines up with 4 and -1. And if you start from the beginning, from the origin, this middle point is technically 0, 0 here. You go 1, 2, 3, 4, and then you go down 1. Then with D, you have, if you draw lines, it would line up with -3s both times. So, sorry, not both times. -3 on the horizontal, and then +3 on the vertical. And then E rests on this line, which means if you start from the middle and try to go left and right to match E, you're already there, so it's 0. And if you try to draw a line to match where it is, you see that you would get to 0 here. So it's 0. And then to go from here down to E, you'd have to go down 3 steps. Or you can see that E matches up with the number -3 here, and you could write that. That was just a little bit more practice on how the coordinate plane works, because it's very important to understand for Scratch. Okay, moving on. In Scratch, you have things called sprites. Now, it's not very important for our course that you know how a sprite works, but basically, it's just the character, and each sprite has its own code. So you can have 2 different sprites having 2 different code. Two different programs. And that's really it. You don't have to know anything else about sprites for this course. Just that, and we're actually not going to be doing any projects with more than 1 sprite, so you don't really have to worry about this. Now we can move on to blocks, starting with the most important block. It is the when green flag clicked block. Now, this block, if you just read it out loud, it says when green flag clicked, which doesn't make sense. So what about when green flag clicked? And that's because you need to have something else with this block, otherwise it doesn't do anything. What it means is, when the green flag is clicked, it's going to do all the stuff that's attached to it. And we'll see how that works later. Basically, if I had blocks attached to this, it would run them when I click the green flag. Moving on, we have 3 basic movement blocks. We have move 10 steps. That 10 can be any number. It's just 10 is the default. And then we have turning right and turning left. We're going to go into the move 10 steps first. So basically, what the move 10 steps block does is, it's very self-explanatory. Whatever direction the cat is facing, which when you start up Scratch, it faces to the right, it's just going to move in that direction 10 steps. Now, a step is just a really small distance. So however much this little increment is, that's 10 of them. So one of them is like really small. The other 2 blocks, the turn blocks, are a little bit more complicated because they have to deal with degrees, and you likely don't know what degrees are in your grade level. So I will basically explain just the 2 main numbers on degrees. So if someone asked you to turn to the right, just if you were standing up and your teacher said, turn to the right, you would do what we call a 90-degree turn. So if I was facing, let me get the whiteboard out again. If I was facing, let's say, here, if I have my stick figure and I am facing this way, actually, it's better to do a top-down view. So let's say you have your line of people, right? You're all in a line, and your teacher's in front of you, like this. You're all facing forward, right? You're all facing the teacher. I'm just not going to draw the rest of them. You're all facing the teacher, and the teacher tells you to turn to the right. Now, you would likely do this. You would turn so that you're facing the person who's to the right of you, like this. This is what we call a 90-degree turn, where if you were to say turn to the right 90 degrees, this is what you would do. You would go from facing forward to facing right like this. And if you did it again, you would face down, and if you did it a 3rd time, you'd face left. And if you did it a 4th time, you'd face back where you started. Now the other way is a 180-degree turn. And this, a 180-degree turn, is when the teacher asks you to turn around. If the teacher asks you to turn around, you would face this way instead. That is a 180-degree turn. So hopefully that clears things up with degrees. You don't have to know any numbers besides 180 and 90 and how they work. So this is a 90-degree turn when you go from up to the right. Up to right is 90 degrees. There's 90 degrees between them. And going from up to down, a whole turning the opposite way, that's 180 degrees. So, showing you how it works in Scratch is the cat starts facing to the right, and then whoever's controlling this clicks the turn 90 degrees button 3 times or so. So the first time it goes from facing right to facing down to facing left, and then facing left to facing up. And that is a 90-degree turn. Now the 180-degree turn is just, it's flipping back and forth, which is what you would expect. You're either facing right, oh, you turn around, you're facing left now. Same thing. The next block is a look block, and that is like speech bubbles. And they're what we're going to be using to print out outputs in our program. Basically, it just puts a speech bubble on the cat that says whatever you put in this bubble here, and it lasts for this many seconds. It's that simple. The next 2 blocks they're very much related to the coordinate plane. They are coordinates. And what they do is they just move the sprite to a point that you write down. So for example, if you wrote a go to XY, it would just teleport to that point. So let's just watch it go. So, in this example, we have glide 1 seconds to x0, y0. So, what is x0, y0? Well, if we look at our coordinate plane, x0, y0 was just the middle. It's the origin. So, that means that the cat is just going to move to the origin. And this glide means it's going to go there smoothly. And how fast it goes depends on the number of seconds you put in here. If you put a lot of seconds, it's going to take a long time. And if you put like half a second, it's going to be fast and get there really quickly. Now, the go to block is basically the same thing, but simpler, because instead of having an animation, it just teleports straight there. You can put any number you want. This 0, 0 is the same as all of these numbers. So if I put 1, 2 into this 0, 0, it would like go. The cat would go right here where this B is. Obviously, the Scratch screen is a lot larger than 4. It's like a few hundred. So you would have to write something like 100, 200 to actually see it move. But my point still stands. The next one has to do with what direction the cat is facing. This is likely the one of the most complicated blocks of this lesson, and it is the point block. What happens is it points the sprite in the direction that you write down. So this number is a direction, and really what you can think of it as, if you remember the degrees from earlier, how if you start facing up and someone tells you to turn 90 degrees to the right, or just turn to the right, you would face this way. Now, if you say point in direction 90, this is 0, this is 90, this is 180. So you start, if someone told you to point in direction 0, it would mean just face straight up or forward. Now, point in direction 90 means face to the right, because you're you just turned 90 degrees. From 0 to 90, the difference is 90. So you turn 90 degrees. Now, if you want to turn another 90 degrees from this one and go... So if your teacher asked you to turn right, and then she asked you to turn right again, you would end up facing this way, which is 180 degrees. And now, if you want to face left, you can think about it 2 ways. It's either turning another 90 degrees to the right from 180, which would be 270, or you can think of it as, instead of turning right from 0, you're turning left. So it could be negative 90 degrees. Either one works. It's not that important that you understand what numbers correspond to what. It's just the fact that the point block, instead of turning you, because if someone was facing this way and you said turn right, they would end up facing this way. But if someone was facing that way and you just said point to the right, they would face this way. So it's different. It lets you do different things. That's the important bit. It's like how stepping is different from making the sprite go to a specific point. Here are the examples. If you type in each of these things, the cat will point in the corresponding way. So 90 is to the right, 180 is down, negative 90 is to the left, and 0 is up. Now, the next two are change x and change y by some number. And what that does is it pushes the sprite in either up, down, left, or right, depending on what block you use and what number you use. And that's all it does. It just takes the cat and pushes it in a direction. So if the cat was at 100, 0, which is to the right of the center, and you say change x by 10, the cat will move a little bit more to the right. And what's important about this is it allows you to move the cat without using the step block. And the step block always makes the cat move in the direction it's facing. So this allows you to make it not move in a direction it's facing. Like so. So we have change x by 10 here, which means we know x, well, let me explain by saying x and y are your two numbers in your coordinates. So this here would be your x and your y. It doesn't really matter. Really think of it as horizontal, vertical, and they just happen to be called x and y. So we have change the horizontal by 10, which means add 10 to it. So if we took this 3 and added 10 to it, where would this point go if we take this 3 and added 10 to it? Now, negative 3, well, so let's use positive numbers for easier math. If we take this 1 and added 10 to it, it would become 11, and you'd get the point 11, 2. Now, 11, 2 is way further. It's all the way over here where 11 is, and then up here, right? So this point versus this point is just moving to the right. So if you add to the horizontal number, you're moving it to the right. Now, if you subtract from the horizontal number, you will move to the left. And the same is true for up and down. So, when we change x by 10, we are adding 10 to that first number of the coordinate, hence moving the cat to the right. And similarly, with the y, if you change the y by 10, the second number, the up-down number, it will move up. And if you put negative numbers in these blocks, it will just move in the other direction. It'll move left or down. Next, we have set x and set y. Now, you already know how these work if you know the go-to block, which we already just talked about. These are basically half of a go-to block. So the go-to block lets you just set the coordinate of the cat. The set x and set y let you set one bit of the coordinate to whatever you want instead of both bits. So, if the cat is at 100, 0, which is to the right and in the middle, and you set its x to 10, it would jump closer to the middle. So if you see it in action, setting x to 10 here means if we draw a line here, a vertical line, where x is 10, it's just going to jump to that line. So we have right here, if I paused it, like when the cat was over here, its x was some negative number, and then it immediately jumps to 10. And then similarly, if it's already near 10, it'll just move a little bit. And if it's somewhere over here, where it was a minute ago, which is also a negative number, it jumps to 10. That's really all it does. It just teleports the cat left or right, depending on how far away it is. It might not teleport the cat at all if it's already on that point. If you understand how the horizontal worked, the vertical is exactly the same. It's just the y value, and it's like a horizontal line that the cat jumps to instead of a vertical line. It's really the same thing, except horizontally except vertically instead of horizontally. The next block And the most common and most simple block is the wait block. It just pauses the code for however long you want. The reason you would use this is to just watch your code run, because if you don't have these, the code's going to run way too fast for you to watch. That's really the only reason you have it here. Now I'm going to show you some examples of one-block programs and maybe show you how they work in Scratch. So, as I said at the very beginning, you have a when green flag clicked button. So if you read these, they say when green flag clicked, move 10 steps. So if I load up Scratch here, and I create that project, that when green flag clicked, move 10 steps, what's going to happen is this. When I click this green flag, the cat will move 10 steps in the direction it's facing. So it's facing to the right now, it moves 10. If I change the direction the cat is facing to this, now it's like facing like this way, is like diagonally down, it's going to go the way it's facing. It's going to keep doing that every time I click the green flag. Really, that's how that works. Now, we have another one which is turn 15 degrees. And if I do that, instead of move 10, it just rotates the cat around like this. Now, if I do the 90 degrees like we've been used to, you'll see that the cat does that same flipping motion that it did in that GIF earlier. Now, the say hello and say hello for 2 seconds blocks are what you'd expect them to do. If I put a say hello for 2 seconds, the cat says hello, and then 2 seconds later, the speech bubble disappears. Now, the difference between say hello and say hello for 2 seconds are this. If I click this green flag, when green flag clicked, say hello. So I click the green flag, it says hello. If I wait here, this speech bubble never goes away. But if I say hello for only 2 seconds, the speech bubble will go away after 2 seconds. That is the main difference, and really the only difference between those two. Some more are the point and go to and change blocks. So, your point blocks say, this says point in direction 90. As we said earlier, direction 90 is to the right. So this cat's facing up right now, so when I click the green flag, it's going to change to the right. There you go. If I press it again, the cat will continue to face to the right. Yep. And if I scramble its direction and click it, it just jumps straight back to the right. I can change this number to 180 to mean down. It in fact gives you a visual of what everything is. So you can drag this around and it actually puts in the number for you, which is useful sometimes. So if I want it to face to the left, negative 90. There you go. Down, 180. Up, 0. There you go. The next one is the go to block. You've already seen how this one works, but now we have it with the green flag click thing. So, if I set the cat to 0, 0, real quick, and let's change its direction to what it started at. And if I go to 100, 100, think about it again like the coordinate plane. 100, 100 is going 100 steps to the right, and then 100 steps up. So the cat should end up somewhere over here when I click this green flag. And it does. Now if I changed this y to negative 100, and I went back to the middle, the cat would go to the right, and instead of going up, it would go down. Like that. The next one is the change x by some number and change y. So change x means that wherever the cat is, it doesn't matter, you're just going to add this number to its horizontal number for its coordinate. So if we have our coordinates again, it's going to add 10. Like we said earlier, adding 10 moves it to the right. So when we add 10, it moves it to the right. And if we add negative 10, which is really this is just subtracting 10, it moves to the left. And we can make this number really big to jump a lot. Or we can switch from change x to change y and move up and down by doing the exact same thing. Just like that. So, those are the main blocks that we'll use. Really, we're only going to be using a few of those blocks. mainly the moving blocks, or more importantly, the look blocks, which are the most simple. The ones that the cat just says what you typed. These ones right here. They're the most common ones we're going to use, along with the wait blocks. And there are a bunch more. If I go to Scratch right now, there are way more blocks than that. But we don't care about most of them, and they're just overly complicated for what this course is about. So we're not going to talk about most of them. And if we do, we will learn them on the spot to not overwhelm you. And that is all. We learned about the coordinate plane, a little bit of how degrees work, and the basic blocks of Scratch. The most important ones being the speech bubble blocks and the change x by or y by blocks, the turn blocks, and the move x steps block. That is all. Thank you.